So I'm back here in Begman Hall, mainly to play with toys. I didn't want to bother dragging all the way to my house. And I have a few different kinds of discharge lamps. So there's a tube here filled with gas and electrodes at either end. And when you turn this on, this passes an electric current through and lights up the neon. So this is the familiar neon of various kinds of illuminated signs. And it looks a little washed out in the video, so we'll maybe try this at a couple of different distances and see if one's better than the other. But what I wanted to point out is what neon looks like when we put this diffraction grating up to it. So this is a piece of plastic that has a whole bunch of different little lines etched into it. And when you actually look at the neon light through this diffraction grating, you can see the color spectrum of neon. That is, the different color photons that are coming out of neon that collectively give it this orangish look. So every time I've done this, I've gotten the wrong orientation, but I think that's right. So here we go. This is neon now through the diffraction grating, and you'll look off to the side of the neon. You can see the various color bands that are being produced there by neon, lots of yellows, oranges, and reds. Now, unfortunately, this doesn't look as great here as it does if you look through the diffraction grating directly at the neon, but hey, we're all doing the best we can here. I'm going to just try this and see if it's better or worse when we are further away. Looks about the same to me. So that's the spectrum of neon. Here is, let's turn this off. Here's the spectrum of hydrogen. And again, we looked at all of these in the simulation. Light up some hydrogen here. To my poor color vision eye, it looks kind of bluish. Now, if we do this, you can see those, at least a couple of the major bright lines of the spectrum off to the side. We get some violets and blues and sort of bluish green that are distinct lines of that hydrogen spectrum. One last one of at least the pure element that we have is helium. So here is a helium discharge lamp. I don't know what color I would describe that as. That's never been my forte. But look at it through the spectrum. You see that I have the thing turned the wrong direction. There we go. Off to the side, we're getting all of those color bars. So I'm seeing some purples and blues, maybe a teal, and a yellow, and one thin sort of orangish red that is part of that spectrum. So this is one of the things that astronomers can use to figure out what the heck is in the stars that they're looking at. If you looked at starlight with a spectrometer, you can actually use that to deduce what kinds of materials must be making up the star that you're looking at. I'm going to show you one more, since our focus was talking about fluorescent lights. Here's a fluorescent light mounted on a tube. I'm sure everybody's well familiar with fluorescent lights from years in school. There we go. Fluorescent lights up, washes out the video. But now here's the, if this works, fluorescent spectrum. Let's turn it the right way. So you can see that fluorescent light is not actually all the colors of white light, but rather it is a few colors that mixed together approximate a white light. And if you've ever experimented or bought different fluorescent lights, you'll know that they sell them in quote-unquote different temperatures. Really, they're using different phosphors to produce a different set of photons in each case, and the mixture of those photons together approximates white light, but does not actually have the complete colors of the spectrum like sunlight or even the light coming from an incandescent light bulb does.